Hello guys, welcome back. So here we have another question on network theory from GATE EC 2015. In the circuit shown, the average value of the voltage VAB in volts in steady state condition is dash. So here we have the circuit. So we have a sine source, and then this side I think this is 5 volts. It's a DC source, and in between we have a resistor, capacitor, inductor and another resistor. So let us try to get the average value. So in DC sense, we know in steady state, capacitor will be open and inductor will be short, right? So we can also solve this by using superposition principle, where first we take one of the source, find the VAB average value, and then take the other source and find the average value, okay? So in this case, if this is open, so in this side node, what will be the voltage? This is gonna be short and this is gonna be open. So this open and short. So at A node it will be 5 volt and this side it will be 0 volts. So what is VAB here? It is gonna remain at steady state of 5 volts, constant 5 volt, right? So now in the other case what happens? When the sinusoid source is on and this we short. Since it is voltage source, I am shorting. If it is a current source, you need to open it out, right? So now if you observe, this is a linear circuit. So to linear circuit, you are giving a 5 pi sine of 5000 t. So what will be your output? Let me call my output as VAB. For a linear circuit, we know that your output also should have some amplitude scaling, right? And it will also be of the sine form and it should have the same frequency. So it should be 5000 T and there can be a phase shift. So only the amplitude and the phase changes. These only change. Your frequency remains same. So this is similar to your signals and systems h of j omega, right? If you give an input of some, let's say, sine of omega naught t, then your output will be mod h of j omega sine of, if you have a factor here, you will have a factor here, sine of omega naught t will be same and this will be mod omega naught, right? J omega naught plus angle of h of j omega naught. So this value is sampled at omega naught and it occurs at your as your amplitude scaling and your phase shift. So here also it is the same because this is a linear circuit. So whatever you do, what is this VAB going to be? Your VAB is going to be some A sine of 5000 T plus some phi. Now they are only asking for the average value. So what is the average value of sine with any phase shift and amplitude scaling? It's gonna be equal to 0, right? VAB average is equal to nothing but integral over one time period A sine of 5000 T plus phi into dt. This is gonna be equal to 0 because sine over a single period is going to be equal to 0. So using superposition, your VAB average is equal to 5 volt plus 0 volt, so which is finally equal to 5 volt. So it is very simple. So other important thing to take care here is your sign. You should not consider this as AB because the figure itself is given that way, that we'll always visualize it in this manner. But if you actually notice properly, it is AB in this direction. So the answer is 5.